So, hello, can you hear me? Hello?
Yes, Chief.
Yeah,
Can hear.
Yes, yes, Chief.
okay. So,
Yes, yes,
instead,
yes, Chief.
instead of the central girder, what we do, we put a side girder here, which is watertight, and another side girder we put here, which is also water. Then what will happen? This is the, for an example, one center, one port, and one stop. So we have divided into three transversely. There will be three double bottom tanks in as means the sideways. So and we can put we have put the longitudinally we have put the in way of transverse bucket we have put the watertight floor. So longitudinally also we have divided. So this is the way it is done. So the if it is only one longitudinal watertight, that is the central girder. But modern ship, as I told you, it will be 3 to 4 tanks on transversely we have. Now let's see another diagram of double bottom tank. In this is the side girder, this is the center girder, and here this is the bottom longitudinal, this is the tank top longitudinal, this is the tank top, and the center strake, why it is separate name. Whenever there is a separate name given, there is some reason. What is the reason? It is the same plate, but this is stress is high, so in the thickness the scantling is slightly higher than the other plates, like we have seen the till plate here, which is the thickness is slightly higher than the garboard strake or the bill strake. So exactly same. The center strake will be having slightly higher dimension, that is the thickness of the plate. This is the margin plate. Now tell me one thing. This margin plate and the other one I have shown you a margin plate. Are they same? Is there any difference between these two? But both are called margin plate. Here it is written margin plate. There also it is written margin plate. So any difference? Can you see any difference between these two plates? Anybody wants to answer? So, okay, this margin plate, this is also a margin plate. In that diagram, what you have seen, this is also margin plate. But in this case, the margin plate is angle is sharp angle. It means, but in this case, also there is it is not horizontal. Slight inclination is there so that the what liquid can get accumulated at the side, and there are build well at the side, and through that it can be pumped. So any plate at the end, towards the end, that is transversely it is placed, and this plate is having slight inclination, that is called margin plate. It's not necessary it will be like this. This inclination is high inclination. But whereas this is also is called a margin plate, which is facilitating the your liquid to get accumulated at the site, and then it can be removed from the compartment. So then these are the this diagram. Can you visualize all the components? What is it given here? Look at all the components. What is it given? This is another way it is being given, the double bottom tank construction. But if you look at it, it is same. There is no difference. If you have the solid floor, you have the bracket floor, and then you have this is the lightning hole, and you have the side girder. Now, in this case, tell me, it is how many tanks it is made. We have told that transversely also we divide the tanks. In this case, how many tanks you have at the double water in this structure. I have told you it can be three, it can be four, it can be two. Okay. So how many, from this diagram, what you can make out? How many tanks it has got? One, two, three, four. How many? Anybody wants to answer?
Three tank.
Three, sir. Three tank.
Uh, Now, if you see, uh, this is the center girder. Center girder is, there is no hole. Is there any hole? You can see in the center girder, there is no hole.
No have.
So in the side girder, you can see this and this are same. Side girder is always in pair. If one is on the port side, another one will be on the starboard side. The side girder has got a hole. So what does it mean? It is three tanks because this is not watertight. And if it is three tank, definitely the center girder will not be having a watertight flow. Center girder will not be watertight because in that case, what will happen? If we cannot make tank, it has to be symmetrical. We cannot make two tanks here, one tank's half width is one tank. Our ship is always symmetric. So if we have the three tanks I had drawn, in that case the side girder was water. There was no center girder. Suppose we remove this center girder, this side girders, we make it watertight. Then what will happen? One, two, this complete from here to here one tank, and this is another tank, so three. Is it clear? Understood? And your
Yes.
four of you still not joined back. So ask them to participate. Or let me send another invitation. Those has not.
Sir,
Four of you has not joined in this session. Because
just upon us speaking.
it was all of you were joined earlier. It was 20. But after second session also was 20. Now four of you. And let me send another invitation. Okay, I have sent already. Let them join. So
Just upon us speaking.
yeah, Sophanis, tell me.
Uh, can it be four tanks? Because the side girder, which is at the end, we don't know if it is watertight or with holes. So it can be also the curve. Also can be the
Are you talking about this part? This one you're talking about?
yeah, yes.
Yeah. This one is like we'll be considering in that case. This will be not a tank because this is a this we cannot see, but it will not be a tank because this small tank will not be there. It will be for the building purpose. It will be. It means we have it is not shown the bilge well. So the water will get collected here, and there will be this there is a hole, and there will be strainer through which the water will come down, and that will not be a part of the tank. It will be a building arrangement. Like the other one, if you see here, it is clearly shown. This is the this is also a part. This is a margin plate. Margin plate is solid, watertight, but the water will get collected here. But in this case, what will happen? The water will get collected. There is a hole which will get collected, and then it will be pumped. So
Okay, thank you.
now let's, if you have all of you have understood this structure, let's move to the next. So we have covered this one, and then now tank has to be tested. How will we test the tanks? tank is tested. Uh, so it will be hydraulically or the air test has been done. So this has been tested. Usually it has been tested this way, like we overflow the tank through the vent. Hence we have a vent through which we overflow, and your vent DB tank is at the bottom, and your vent is coming out. The vent pipe will come out to the upper deck, and then at the upper deck you have the above the upper deck will be having the vent, and this vent is the water should be coming out through that vent. And you have seen in the hydrostatic that it is the height of the water, how much pressure it will be. The pressure will be very, very high in that case. Though the diameter of the pipe is compared to the tank, it is less, very small diameter compared to the tank. But the height will be from the DV tank, you can imagine it will be penetrating the upper deck. So that height will be subjected to the tank, and that is accepted by the classification society. That is the way pressure test is being done. Now the vent, if you see the vent, it means why the vent is provided. It means each double bottom tank will have air vent, and you will be having the sounding pipe also, because it has to be checked that how much water is there. Suppose you want to make a manatee, you need to make it dry, so you need to, and plus you need to maintain because of the what how much volume, the mass you need to add for the stability purpose also. So you need to know, check the how much quantity is there in the tank. So the if we see the vein, it means a vein has to be such a way. Vein name itself, like it is actually air vein, isn't it? But it's not only does the, it means if you see this diagram, it has to be provided with a vent. This is not for the DV tank, because this is the tank top, that is the, for an example, TST. Because DV tank, it will, this will be the upper tank, and the pipe will be penetrating to the upper tank, and it will touch the, it will be uh, attached to the DV tank, that is a tank top. So in this case, what will happen when you fill up a tank, it will fill up through it, and it is passed through it, and then the float is resting at top, at the bottom. So what will happen? Water will come out, and it will come out through this. And when you are filling, air has to come out, because tank should not get pressurized. The air will come out. It means when it is escaping from the tank, it can escape water as well as air. But when it is moving inside some air, when you are developing, that time air has to occupy. Otherwise, it will create vacuum and tank will collapse. So it will air will enter, and it will occupy the vacant space inside the tank. But whereas if the water is trying to move inside, get inside because of the high seas, then what will happen? Water will enter into this, and once water is entered, the float will move and float will cover this. And once it is covered, water will not be able to move inside the tank. It means only the air can enter into the tank, and the water and the air both can come out from the air vent. So this is the air vent we have, and what we do, we fill up, complete the tank, and then overflow through this. And we can imagine, as I told you, the height of this pipe. This pipe is 760 millimeter from the upper deck. From upper deck, the tank top height is very high, depending on the size of the vessel. So that height of the water column is accepted. That is enough to do the testing of the your DV tanks. So that is the way DV tanks are tested. And this one, it's not necessary it will be the float, this type of float. You can have the another thing you can have, that is the this is also a float, that is not flat float. This is the bed. So it is resting at the bottom, and once water trying to enter into the tank, this will move up and this will close this passage so that water will not enter into the tank. So both arrangement we have and we overflow this. This also will overflow if this is if water is coming out, it will come out from the tank. So that is the way we do the pressure testing on the digitals. So why we do the pressure testing? So that we confirm that there is no deformation, distortion on the plates. So after that we check the tank condition. So outside condition we check, by which we come to know that the tank top is not distorted. Now, in the way of machinery, the double bottom tank is slightly different requirement of construction, because there is a concentrate load. As we know that the engines are placed, engine are placed in a particular position, location. The engine weight is very high, so that is the reason there are different requirement for the in way of engine. Whereas in the cargo space, if you see, once you load it, for an example, in tanker, you have loaded the cargo, complete double bottom, the tank top will be loaded equally, because it will be distributed throughout the tank. Even for the dry cargo, it will not be concentrated. It will be spreaded around the on top of the tank top. But whereas the machinery, wherever machinery is placed, this problem is there. There will be concentrate load, and that area requirement is different. Even for the, if you see the deck crane, wherever you use the deck crane, if it is a self-contained ship, that is the cargo gear if it is having, then the deck crane will be placed in way of your transverse bulkhead, because that transverse bulkhead having the watertight structure, heavy structure, as well as double bottom tank, there is a solid floor which is water. So it can take the strength of this. That the strength is sufficient to take that load, because that is also crane also is a concentrate load. So wherever the machinery, heavy machinery is kept, so this is the way. Then what is the requirement for the double bottom tank in way of machinery space? It is the transverse, that is the floor plates. It means the you cannot have bracket floats in certain areas. Certain area you have to have solid floor. It means the transversely flows are placed transversely. That has to be solid floor. And there are other requirements also. We'll see before we go into that. Let us see this type of structure. It means this is the, it is shown watertight, your solid floor, and then we have the longitudinals. It is shown in this diagram, which is tank top longitudinal as well as bottom longitudinal. And tell me, what type of ship is this? Anybody? So this inside there is beams also. So this is a tanker, and the double bottom structure is this, because this will be flat, and then there is a slight slope, because at the corner we don't want, if it is a corner, we don't want it. So sometimes it can be straight also to the tankers, but this strip is kept slightly inclined so that the accumulation at the corner will not be there, because oil also will have some impurities and all, which we don't want. So now let us see what is the other requirement for the double bottom construction in way of machinery space. So the frame space in framing system has to be solid floor, solid plate floor. But solid floor does not mean it's watertight. Whenever we are dividing a tank, that floor will be watertight. Like the sump tank. Sump tank, it has to make a compartment, and that floor, it will have two floor. In between there will be also floor, but the end floor of the sump tank will be watertight. and in between two end, there will be number of solid floors. Those will be solid floor. You cannot have bracket. So if you enter into the some tank, you'll see that all are solid floor. So you'll have to. There is no bracket floor inside. So this is the requirement because our engine is very heavy. So engine load has to be taken by the double bottom structure. So and additional side girders also are fitted. It means in outboard to the engine there will be side girders because once you add side girders, it is giving you it is longitudinally placed and it is giving you a longitudinal strength. So that is the reason. Additionally, there will be extra side girder will be provided in way of engine room. Whereas that side girder will not be extended to the cargo area because that will be only for the concentrated load in your engine room. Other side girder will be passing through the whole complete ships. So now height of the engine room also that the bottom floor that is the tank top has to be raised. Why it is raised? One reason we accommodate tanks. This tank is used for lube oil or the fresh water. We use for the fuel oil, the diesel oil. We use so the capacity is increased at the same time. What we achieve, the engine is also raised. Then the alignment of the shaft will be for that we do require to raise the engine. So that also helps. It does the two purposes. As one is alignment, another is we can use those tanks. The capacity will be sufficient. We can use it for the keeping lubricating oil, fresh water, or the fuel oil. That is the reason it has been raised. So and shaft alignment because your propeller, if the engine is lower, then what will happen? Your shaft will be lowered, and if your shaft will be lowered, your propeller blade cannot be projected out of the keel. It means the diameter of the propeller will also reduce, which we don't want. So that is the reason we need to raise the shaft to accommodate the larger diameter of the propeller. Efficiency will be high. So we have the engine, that means the in way of the engine room, the tank top has to be raised. And the seating also has to be raised. That is the engine seating. So if we see this in this case, Safines, tell me.
Thank you, Chief. So, when you say to accommodate the diameter of the propeller, you are saying that the propeller will be below the ship's keel, or I don't understand.
So this is let us see this way. So what I told you that this is our stern and we have the shaft, center line, we have the engine. Now suppose engine, we don't raise engine ready. So what will happen? The engine output, this is the flywheel center. Flywheel center will be lower. In that case, what will happen? Shaft center also has to be lower. Once the shaft center is lower, shaft center is here, and now suppose shaft center is. Then what will happen? Only this space we can use. So the diameter will be, it means this will restrict the diameter because it cannot be projected out. The diameter of the propeller has to be reduced. Whereas if the shaft is here, our diameter can increase because this we can use a larger diameter because now this is the center line and here this is the center line. So we need to raise the engine to have the alignment. Otherwise, this diameter, this center line will decide where the engine will be. Engine can be on the lower portion. If we don't raise, suppose this is the tank top
Okay.
throughout the ship. So this portion has to be raised so that we can have this distance, higher distance, which is deciding how much will be the diameter of the propeller. Yeah, understood.
Yes, Chief. Thank you.
So if we see this diagram, you have raised the floor, and now in this diagram, if you see, this is a solid floor because it is not in bracket. Now this is the center girder, but in way of the sump tank, because this is the sump tank. Your engine will be at the center if it is a single propeller. Now this center girder in way of sump tank, it will not be the watertight girder. So it will be, this will be there will be lightning hole in the center girder because some tank is one tank. It is never two tanks. So, and then you have the side girder. In the side girder will be watertight. This girder, this two, it will make a compartment which we use for the sump. But sometimes is only in the way of main engine, under the main engine. There will be other tanks also in the side and the forward knob. Now this sometimes there is a requirement where this some tank cannot be divided with the other tank by single bulkhead, single partition. So in that case, what will happen? We'll have to make another girder, that is the side girder, which is watertight. So these two girders are watertight. These two girders also watertight. Now we can have a tank here. There is no problem. This can be here. It is shown that diesel oil tank. This is diesel oil because now this diesel oil is separated from the lube oil by two partition. Now in between this, what will happen? This will become a coffer. We cannot put any liquid. So these two will be watertight, and then now the strength is requirement is high because we will be putting the engine. So there will be this at the side, there will be flat bar because to take the strengthening the solid floor. So these two others flat bar, it is welded on the solid floor. And then these are the scallops. It is shown here, all the scallops, and then on the top where the engine will sit, because engine, the two-stroke engine, very heavy structure. So what we have a heavy plate seat we have on the top, but this is not a doubler. You can have this plate extended up to throughout, and we can have a doubler plate, but this is not a doubler plate. This is an insert plate because insert plate is a requirement if you have a doubler. This plate is welded by this stiffness, the heavy plate, or the girder, side girder, and the solid floor. But your thick plate, which is engine will be sitting, will not be welded onto these internals. It will be welded only on the side of the plate, tank top. So what will happen? This strength will be less for this plate because this plate will not be attached to this. This heavy flat bar stiffener will not be welded to the thick plate. Usually for the four-stroke, two-stroke engine, it is 40 mm thick plate. It is very heavy plates, and if it is not welded here with this structure, then this will not give you much strength. Only it will be at the side. It will be welded. That's the reason it is an insert plate. Insert plate means this plate is welded at the side. Underneath, there is no plate extended, this one. And this plate is welded, all these internals are welded onto this. Whether it is solid floor, whether it is heavy plate seat, whether it is the side girder, all will be welded onto this plate and it will give you larger strength. So that engine can be sit onto that heavy plate and it will not It will withstand all the force produced by the engine, whether it is for the uh, static, that is the your weight of the engine, as well as the during the operation there will be load, cyclic load. So there